What if I told you that right now, something from another star system is racing through our cosmic neighborhood at 130,000 miles per hour, carrying secrets from a place we've never seen, from a time before our sun was born? What if this visitor isn't just passing through, but watching? Tonight, we uncover the chilling story of 3I/Atlas, the stranger between the stars, and what it might be hiding from us. Because in the summer of 2025, astronomers detected something that doesn't belong here, something that defies our understanding of comets, challenges our theories of planetary formation, and forces us to ask a question we're not sure we want answered. Are we alone in receiving these visitors? Or are we being studied? Picture this: the velvet black of deep space, billions of stars scattered like diamond dust across an infinite canvas, and cutting through that darkness, unseen, unheard, unstoppable, a wanderer from the galactic deep, not born in our solar system, not governed by our sun's gravity, a stranger with no invitation, no warning, no explanation for why it chose now to arrive. The universe, it seems, is not silent. It's sending messengers. Let me take you back to where this story begins. July 1st, 2025, 3:42 a.m. Universal Time. In the Atacama Desert of Chile, one of Earth's driest places, a robotic telescope named ATLAS, the Asteroid Terrestrial Impact Last Alert System, was doing what it does every clear night, scanning the heavens for threats, asteroids that might one day collide with Earth, space rocks tumbling too close to our fragile blue marble. But that night, ATLAS caught something else entirely. I imagine the moment like this: the algorithm flagging an anomaly, a single pixel moving against the starfield. To the untrained eye, just another speck among billions. But to the software designed to calculate trajectories and orbital mechanics, this speck was screaming warnings. The numbers didn't make sense. When astronomers first caught a glimpse of 3I/Atlas, it wasn't just another rock drifting through space. It was something different. Something fundamentally alien to our solar system. And I don't use that word lightly. Within hours, other observatories confirmed what ATLAS had found. Pre-discovery images emerged from archives. The Zwicky Transient Facility in California had photographed it on June 28th and 29th, then June 21st, then June 14th. Someone even found an image from May 21st, buried in data from Israel's Weizmann Observatory. This thing had been sneaking up on us for months. Here's what made it extraordinary: the trajectory. Every natural object born in our solar system follows an elliptical orbit around the sun, like Earth's nearly circular path, or even the stretched ovals of distant comets. These orbits are closed loops, gravitationally bound to our star. 3I/Atlas ? Its orbit was hyperbolic. Not a loop at all, but a cosmic spear cutting through our system in an almost straight line. The orbital eccentricity, the number that describes how curved or straight a path is, measured 6.141. For context, Earth's eccentricity is 0.0167, almost a perfect circle. Anything above 1.0 means the object is moving so fast it will escape the sun's gravity forever. But 6.141, that's not just escape velocity, that's barely even bending as it passes our star. Do you understand what this means? This object came from interstellar space, from the region between the stars where the nearest neighbor is 4 light-years away, 25 trillion miles of frozen void. It had been traveling for potentially millions of years, drifting in the galactic dark, until by some cosmic coincidence, or perhaps not coincidence at all, it found our solar system. And the speed, 130,000 miles per hour relative to the sun. For comparison, that's nearly twice as fast as the previous interstellar visitors. Oumuamua, discovered in 2017, was moving at about 58,000 miles per hour. 2I/Borisov, found in 2019, clocked in at around 70,000 miles per hour. 3I/Atlas was racing. But here's what sent chills through the astronomical community. When they traced its path backward through space, projecting where it had come from, the trajectory pointed toward the constellation Sagittarius, toward the galactic center, toward the dense heart of the Milky Way, where millions of stars swirl in ancient orbits, where stellar nurseries birth new suns every century, where the rules of cosmic chemistry are written in violence and fire. This wasn't a wanderer from a nearby star system. This was something forged in the galactic furnace itself. Within 48 hours of the discovery, the global astronomical network erupted into action. The Nordic Optical Telescope in the Canary Islands swung toward the target. The Canada-France-Hawaii telescope on Mauna Kea locked on. The Deep Random Survey in Chile confirmed early observations. And that's when they saw it. The glow, July 2nd, 2025. Multiple independent observatories reported the same thing. 3I/Atlas had a coma, a diffuse halo of gas and dust surrounding its nucleus, stretching 3 arc-seconds across the sky. Small in angular terms, but at that distance, enormous in actual size. The object wasn't just a dead rock coasting through space. It was active, alive, reacting to the sun's distant heat even from 277 million miles away. They upgraded its designation from asteroid to comet, from a simple interloper to something far more complex, something that breathed, that changed, that carried within it the chemical fingerprints of wherever it had been born. I remember reading the first reports and feeling a strange mixture of excitement and unease, because comets, our comets, the ones born in the Oort cloud at the edge of our solar system, are time capsules, frozen archives of the material that formed our worlds 4.6 billion years ago. But if 3I/Atlas came from another star system entirely, from a region of the galaxy where the elements were mixed differently, where the stellar explosions had different signatures, what stories was it carrying? What ancient chemistry was locked in that ice? Here's where the story gets strange. And I mean strange in a way that made seasoned astronomers start using words like unprecedented and anomalous in their papers. Words scientists hate using because they imply we don't understand something. Let me walk you through the mysteries one by one, because each anomaly raises questions we still can't fully answer. Mystery number 1, the color that shouldn't exist. When telescopes photographed 3I/Atlas in early July, they noticed something odd about its coma. It glowed reddish, not the clean ice-white or pale blue-green of typical comets, but a deep, rusty hue suggesting dust composition we rarely see. But here's the twist. Throughout July, observers noticed the color was changing, growing redder, deepening like a wound, darkening over time. A team of researchers published findings in August, showing that the coma's evolving color indicated transforming surface composition. As the comet heated up, approaching the sun, different volatile materials were boiling away in sequence. First one type of ice, then another, each releasing dust grains of different minerals, different chemistry. What kind of stellar environment creates ice chemistry that transforms like this? Mystery number 2, the polarization anomaly. This is where things get truly bizarre. When light reflects off objects in space, it becomes polarized, meaning the light waves align in specific patterns depending on what they bounced off. Scientists use polarimetry to study the dust grains surrounding comets, asteroids, and planets. Every type of dust has a signature. A team of astronomers conducted the first polarimetric observations of 3I/Atlas in late summer. What they found made no sense. The comet exhibited extreme negative polarization, with measurements so far outside normal ranges that it didn't fit into any known category. Not high polarization comets, not low polarization comets, not even the unique signature of comet Hale-Bopp, which had its own weird polarization and got its own special category. The scientific paper's language is telling. This polarimetric behavior is significantly different from all known comets, either interstellar or bound to our solar system. Think about that for a moment. We've studied thousands of comets. We've catalogued their dust, mapped their tails, analyzed their comas. We thought we understood the basic physics of how light interacts with cometary material. 3I/Atlas broke those rules. The researchers concluded that this might represent a distinct type of comet, expanding the diversity of known interstellar bodies. But here's the question that keeps me up at night. Distinct how? Different because it formed around a different type of star? or different because it's composed of materials we've never encountered, elements forged in stellar explosions our sun has never experienced, or, and this is the speculation that circles through my mind like a whisper, different because it's not entirely natural. Mystery number 3, the impossible chemistry. In August, the European Very Large Telescope in Chile turned its UV-ES spectrograph toward 3I/Atlas. This instrument can read the chemical signatures in light like a forensic scientist reading DNA. What they found was shocking. The coma, the cloud of gas boiling off the comet's surface, was rich in nickel and iron. That's not unusual. Many comets release metallic atoms as they heat up, but the ratio was all wrong. The nickel to iron abundance was extreme, far higher than any solar system comet, higher than 2I/Borisov, the previous interstellar visitor. The ratio was so skewed that it suggested this comet formed in a completely different chemical environment than anything in our cosmic neighborhood. Harvard astrophysicist Avi Loeb, the scientist who spent years arguing we should seriously search for alien technology, examined the data and calculated something even more disturbing. Using observations from the James Webb Space Telescope taken on August 6th, he analyzed the mass loss rate and outflow speed from the surface. His conclusion, 3I/Atlas likely weighs more than 33 billion tons, with a nucleus diameter potentially exceeding 3.5 miles. That makes it the largest interstellar object we've ever detected, but Loeb went further. When asked on national television whether his gut feeling was that 3I/Atlas is natural or technological, he gave an answer that chilled me. Most likely a natural comet, but we need to be prepared for a black swan event. Most likely, not definitely, not certainly, most likely. Why the hedge? What does he see in the data that makes him unwilling to completely rule out the possibility of something artificial? Mystery number 4, the trajectory from cosmic noon. Remember how I mentioned 3I/Atlas came from the direction of Sagittarius toward the galactic center? A research team traced its path backward through space and time, reconstructing where it must have originated. Their conclusion points to something called the thick disk of the Milky Way, a region associated with our galaxy's cosmic noon, a violent period billions of years ago when star formation was at its peak. Back then, supernovae ripped through molecular clouds. Stellar winds from massive stars scattered heavy elements across light years. Planetary systems formed, shattered, reformed in the chaos. If 3I/Atlas is a remnant from that era, if it's been drifting through space for billions of years, surviving collisions, gravitational perturbations, radiation bombardment, then it's carrying chemical signatures from a time before Earth existed. It's a message in a bottle from the deep past. But here's what troubles me. Why is it arriving now? Pure coincidence? Statistical probability given enough time? Or is something else happening? Something we can't see yet because we're only now developing the technology to detect these visitors. Mystery number 5, the acceleration question. This is where 3I/Atlas echoes the greatest mystery of Oumuamua. Back in 2017, when Oumuamua was discovered, our first confirmed interstellar visitor, astronomers tracked its trajectory and noticed something impossible. As it left the solar system, it was accelerating faster than the sun's gravity alone could explain. There was no visible coma, no tail, no outgassing that could act as a thruster, yet something was pushing it. Theories exploded. Maybe it was venting gas we couldn't see. Maybe it was actually a hydrogen iceberg sublimating invisibly. Maybe, and this is where Avi Loeb made headlines, it was a light sail, an artificial structure designed to catch stellar radiation for propulsion. With 3I/Atlas, we're watching more carefully. We have better instruments. We're measuring the outgassing, tracking the acceleration, looking for any deviation from predicted trajectories. So far, the comet's path matches what we'd expect from natural gravitational dynamics and solar radiation pressure. So far, but we haven't seen it at its most active yet. We haven't watched it at closest approach to the sun, and that's when things might get interesting. Because if 3I/Atlas does something unexpected, if it accelerates strangely, if it changes course in ways that outgassing can't explain, if it emits signals or patterns we don't anticipate, then we'll have to ask ourselves a question humanity has avoided for most of history. What do we do when we finally have proof we're not alone? Let me take you inside the scientific debate that's raging behind the scenes, because what you read in press releases is sanitized, diplomatic, carefully worded to avoid controversy. The reality? Astronomers are arguing intensely. The naturalist camp, most scientists, the vast majority, believe 3I/Atlas is exactly what it appears to be, a comet from another star system. Weird chemistry? Sure, but that's expected from an object formed in a different stellar environment. Unusual polarization? Fascinating, but probably explained by dust grain properties we haven't encountered before. Their argument is solid. Space is full of comets. Every star system likely has billions of them, scattered in distant clouds like our Oort cloud. Occasionally, gravitational perturbations kick these objects out into interstellar space. They drift for millions of years until, by pure chance, they encounter another star system. We just happen to be that star system this time. The statistics support this. Based on the discovery rate of interstellar objects, 3 in 8 years, astronomers estimate there could be thousands passing through the inner solar system every year. We're just now building telescopes sensitive enough to spot them. The upcoming Vera C. Rubin Observatory, with its ability to scan the entire visible sky every few nights, will likely find hundreds more. Nothing unusual, just cosmic debris doing what cosmic debris does. The skeptics. But then there are the scientists who look at the anomalies and see something that bothers them. Why is 3I/Atlas so much faster than previous interstellar objects? What kicked it to such extreme velocity? Natural gravitational assists can do this. Sure, a close encounter with a massive star or even a black hole could fling an object to incredible speeds, but the odds of it then randomly encountering our solar system, and the chemistry, that extreme nickel ratio, the polarization that fits no category. Some researchers quietly wonder if we're seeing evidence of a formation process we don't understand. Maybe from the accretion disk of a star very different from our sun. Maybe from a supernova-enriched nebula where heavy elements were far more abundant than in our local space. Or maybe, and this is where voices lower and words become careful, maybe we're seeing material that didn't form naturally at all. The Loeb hypothesis. Avi Loeb is the scientist willing to say out loud what others whisper. His position isn't that 3I/Atlas is definitely artificial, it's that we should seriously consider the possibility and design observations to test it. Here's his logic. If a technological civilization wanted to explore the galaxy, sending probes to every star system would be impossibly expensive. But you know what's cheap? Waiting. Set up monitoring stations in interstellar space. Launch them on slow, patient trajectories that take millions of years to reach target systems. Make them look like natural objects, like rocks, like comets, so they don't attract attention. These probes could be passive observers, or active samplers, or even communication relays waiting to detect signs of technological civilizations before making contact. Sound like science fiction? Consider this. We're planning to do exactly that. Breakthrough Starshot, a project Loeb advises, aims to send tiny light sail probes to Alpha Centauri at 20% the speed of light. These probes would be small, simple, designed to look as innocuous as possible. If we're thinking about doing this now, with our primitive technology, what might a civilization 1,000,000 years more advanced have already deployed? Loeb points to Oumuamua's unexplained acceleration and strange, elongated shape. He points to 3I/Atlas's anomalous properties. He argues that dismissing the technological hypothesis without investigation is unscientific. And when pressed, he admits, most likely natural. But we need to be prepared for a black swan event. That phrase, black swan event, is critical. It refers to something so unlikely, so unprecedented, that when it happens, it changes everything we thought we knew. What if one of these interstellar visitors isn't natural? What if just one, among the thousands the Rubin Observatory will find, is technological? The heated debate. I've read email chains between researchers. leaked anonymously of course, where the disagreement gets personal, scientists calling each other sensationalists, others firing back accusations of closed-mindedness. One camp insists that extraordinary claims require extraordinary evidence, and so far, everything about 3I/Atlas can be explained naturally, even if the explanations are complex. The other camp argues that we have a responsibility to check, to design observations that could distinguish between natural and artificial, to take the possibility seriously before these objects pass by and we lose our chance forever. Because here's the thing about 3I/Atlas. By March 2026, it will pass Jupiter and leave our solar system for good. Once it's gone, we'll never get another look. Never send a probe to intercept it. Never answer the questions it raised. Our window to understand this visitor is closing fast, October 3rd, 2025, today. As I write this, 3I/Atlas is making its closest approach to Mars, about 30 million kilometers from the Red Planet, and humanity has mobilized our robotic fleet to watch. ESA's Mars Express orbiter has pivoted from studying Martian geology to photographing an interstellar visitor. Its high-resolution stereo camera, designed to map canyon walls and crater floors, is now pointed at a moving target millions of miles away. ExoMars Trace Gas Orbiter, normally sniffing the Martian atmosphere for methane, has turned its spectrometers toward 3I/Atlas. Nomad, SpyCam, instruments with names that sound like they belong in science fiction are trying to taste the comet's breath, to analyze what gases are venting from its surface. NASA's orbiters are doing the same. Multiple spacecraft, designed for completely different missions, are stealing moments between their regular observations to glimpse this stranger. Why the urgency? Because in late October, 3I/Atlas will pass behind the Sun from Earth's perspective. For nearly 2 months, it will be invisible to ground-based telescopes, hidden in solar glare, untouchable, unknowable. And that period, late October through November, is when the comet will be most active, closest to the Sun, heating up, outgassing violently, potentially revealing secrets locked in its ice for billions of years. If we can't observe it from Earth, we need robots positioned elsewhere in the solar system to be our eyes. The Parker Solar Probe, NASA's sun-skimming spacecraft that endures temperatures hot enough to melt steel, will catch 3I/Atlas in its wide-field imager between late September and November. It photographed comet Neowise back in 2020 and proved it could track comets near the Sun. ESA's JUICE spacecraft, currently en route to Jupiter's icy moons, will attempt observations in November using cameras, spectrometers, and particle sensors. The data won't come back until February 2026. JUICE is too far away and oriented wrong to transmit immediately, but it will be worth the wait. Even Lucy, NASA's mission to study Jupiter's Trojan asteroids, might catch a glimpse. The researchers behind a recent study suggest Lucy could potentially sample 3I/Atlas's tail, flying through the stream of dust and gas trailing behind the comet. This is unprecedented coordination. Space agencies that usually compete for funding and prestige are sharing data, coordinating observations, working together. Because this isn't about national pride. This is about a once-in-a-generation opportunity, maybe once in a lifetime, to study something from beyond our cosmic neighborhood. The amateur revolution. But it's not just the professionals. Amateur astronomers around the world have trained their backyard telescopes on 3I/Atlas. Images flood online forums, some blurry, some surprisingly sharp. People comparing notes on the comet's brightness, its coma's size, the angle of its tail. There's something beautiful about that, something fundamentally human. For all our differences, language, culture, politics, when something unknown appears in the sky, we look up together, we share what we see, we wonder collectively. I've seen posts from observers in Chile, Australia, South Africa, Japan, different hemispheres, different time zones, different lives, but for a few moments each night, they're all looking at the same thing, a visitor from the stars. Some approach it scientifically, measuring brightness, calculating trajectories, comparing data to professional observations. Others approach it philosophically, poetically. I read one post from an amateur in New Zealand who wrote, "Somewhere out there, around a star I'll never see, this comet was born. It drifted alone for longer than humans have existed, and tonight, by pure chance, it's close enough for me to see from my backyard. That's beautiful. That's terrifying. That's everything. The bigger picture." Let me zoom out for a moment and talk about what this means, not just scientifically, but existentially. For most of human history, we believed Earth was the center of everything. The sun, planets, and stars revolved around us. We were special, unique, the purpose of creation. Then Copernicus shattered that illusion. We orbit the sun. Galileo confirmed it. We're not the center, just one planet among others. Then we discovered our sun is one star among hundreds of billions in our galaxy, and our galaxy is one among hundreds of billions in the observable universe. Each revelation pushed us further from the center, made us smaller, less significant. But here's the paradox: we're also increasingly aware that we might not be alone. The discovery of exoplanets, thousands of them now, shows that planetary systems are common, worlds orbiting other stars, some rocky like Earth, some in habitable zones where liquid water could exist. The detection of organic molecules in interstellar clouds shows that the building blocks of life are everywhere. And now, interstellar objects visiting our solar system prove that matter exchanges between star systems, that chemistry mixes across light years, that we're not isolated islands but part of a galactic ecosystem. 3I/Atlas is a thread in that vast cosmic web. It carries information, data encoded in its chemistry, its structure, its composition, stories about where it formed, what stellar events shaped it, what conditions existed in its home system. If we can read those stories, if we can decode the chemical fingerprints, we'll learn not just about one comet, but about the diversity of star systems across the galaxy. We'll learn whether our solar system is typical or unusual, whether Earth's chemistry is common or rare, whether the conditions that led to life here exist elsewhere. And maybe, just maybe, we'll find evidence that challenges everything we think we know, the awe and the fear. I feel both when I think about 3I/Atlas. Awe, because we're living in an age where we can detect and study objects from other star systems. A century ago, this would have been impossible. Even 50 years ago, the technology didn't exist. Now we can measure the composition of a comet, born light years away. We can photograph it, track it, analyze its dust grain by grain. That's extraordinary. But there's fear too, because every anomaly, every measurement that doesn't fit our theories reminds us how much we don't know. What if 3I/Atlas is truly unique? What if it represents a type of object our physics can't explain? What if, and I'll say it plainly now, what if it's not entirely natural? The thought is both thrilling and deeply unsettling. First contact, not with radio signals or alien ambassadors, but with a probe disguised as a rock, quietly observing as it passes through. Would we even recognize it? 3I/Atlas will reach its closest point to the Sun on October 30th, 2025, just a few weeks from now. At that moment, 130 million miles from our star, it will be superheated, ice will explode into gas, dust will stream away in a tail millions of miles long, the coma will glow bright enough to see with modest amateur telescopes, and we'll watch. Every telescope we can aim at it, every spectrometer, every camera, every instrument designed to squeeze meaning from photons. We'll measure, we'll analyze, we'll debate. Then, in early December, as 3I/Atlas emerges from behind the Sun, it will be dimmer, colder, already retreating. By month's end, it will fade past 12th magnitude, invisible except to those who know exactly where to look. By March 2026, it will pass Jupiter, then Saturn, then drift beyond the edge of our solar system into the dark between stars. And we'll be left with questions. Questions about its chemistry, its structure, its origin. Questions about what made it so different from every other comet we've studied. Questions about whether natural processes alone can explain everything we observed. Questions we may never fully answer. Because here's the truth that haunts me. Maybe 3I/Atlas is just a rock, a fragment of a shattered planet from a star system we'll never visit. a natural object following natural laws, unusual only because it formed in conditions different from our own. Maybe the extreme nickel ratio, the impossible polarization, the breakneck speed. Maybe all of that has mundane explanations we just haven't figured out yet. Maybe, or maybe it's something else. Maybe it's a messenger, a probe, an observer sent from a civilization that learned long ago how to seed the galaxy with patient watchers, machines designed to look natural, to blend in, to catalogue worlds and civilizations as they pass by. Maybe it's been transmitting data we can't decode, recording images we'll never see, reporting back to some distant intelligence about the primitive species that pointed crude instruments at it and wondered. Maybe we're not looking at a rock at all. Maybe we're looking at a mirror and something is looking back. The Vera C. Rubin Observatory will begin full operations soon. It will scan the entire visible sky every few nights, finding hundreds of new interstellar objects over the next decade. Thousands, eventually. Most will be natural, ice and rock and chemistry we can explain. But statistics are cruel. If even a fraction of 1% of interstellar visitors are technological, if just one among thousands is an artifact rather than natural debris, we will find it. And when we do, everything changes. First contact won't be radio signals from the stars, it won't be aliens landing on the White House lawn, it will be a weird rock with chemistry that doesn't make sense, an object that accelerates wrong, a visitor that does something, one thing, that nature can't explain. Maybe that object was Oumuamua, maybe it's 3I/Atlas, or maybe it's still out there, racing toward us right now at impossible speeds, carrying a message we're not ready to read. One day, another stranger will come between the stars, another hyperbolic trajectory flagged by automated surveys. Another anomaly that makes scientists argue and amateurs wonder and conspiracy theorists explode. Another opportunity to answer the oldest question our species has ever asked. Are we alone? But here's the final thought that keeps me awake at night, staring at stars I'll never reach. What if we're not? What if we've already been visited dozens of times, hundreds, thousands, and we just didn't notice? What if interstellar probes have been quietly cataloguing Earth for millennia, watching civilizations rise and fall, waiting for us to develop the technology to see them? What if 3I/Atlas isn't the first stranger between the stars? What if it's just the first one we were advanced enough to detect? By March 2026, it will be gone, racing back into the galactic dark at 130,000 miles per hour, carrying whatever secrets it discovered about us to wherever it came from. And we'll be left here on this pale blue dot with our questions and our telescopes and our growing certainty that the universe is far stranger than we ever imagined. The next visitor is already on its way. Maybe it's natural, maybe it's not. The question is, when it arrives, will we be ready?